In lecture 8, we will discuss fourth module topic, that is shift registers. Okay, a register or a shift register. And we will also discuss how values are stored in a register, how we can shift the values internally through the registers, and the four basic types of registers called SISO, SIPO, PIPO, PISO. Okay. Different types of registers also. So we'll start with the basic definition of a register or basic idea of a register. A register is a digital circuit with two basic functions. One is data storage. It is one function. Another function is data movement. Okay, these are the two main functions of a register. So it can hold a value, a particular value, either a 1 or 0 or a sequence of values. If it is a single register, it can store only a one value. And these registers are mainly made up of or contain flip-flops. Okay. If it is a single bit register, it contains only one flip-flop. If it contain if the capacity of register is more than one bit, then there will be more than one flip-flops. Okay. And the storage capacity of a register. Okay. For example, if it is a single register, can hold a single bit, either 0 or 1. Okay. And the total capacity of a register is the number of bits. Each flip-flop in a shift register represents one bit of storage capacity. Therefore, the number of stages in a register determine the storage capacity. For example, if you are considering 5 registers, okay, each can store either 1 or 0. So the capacity of this particular register is 5 bits. Okay. And now we'll see the working of this particular register, or how flip-flop can be used as a storage element. For example, assume that initially the Q value of this particular flip-flop is 0. Okay, this is the initial state of this flip-flop. Q is equal to 0. Now we are going to apply 1 at the input of this particular D flip-flop. And if we apply clock signal as a positive edge triggered flip-flop, this 1 will be transferred to the output side. So this 0 becomes 1. Now 0 is changing to 1 because the present input is 1. And this is the first clock, and if you are not applying any clock after that, this 1 will be maintained at the output side. Okay, so if you continue like this, if you are not applying any positive triggered signal, this 1 value will be maintained at the output side. So we can say that this particular flip-flop will store 1. And now we'll consider another example. Assume that initially the Q output is 1 and the D input is 0, and now we are going to apply clock signal. So again, it's positive edge triggered clock. And if we are going to apply positive edge triggered clock, and we are maintaining the clock like this without any positive edge trigger. So this whenever the first positive edge occurs, this 0 will be transferred to the output side. So 1 becomes 0. So initial 1 is changing to 0. And if you are not applying any value, any positive edge triggered at the input side, this 0 will be maintained at the output side of the flip-flop. So we can say that either a 0 or 1 can be maintained at the output side, or it can store a 1 or 0 at the output side. Okay, this is the basic idea behind the register. And now the shift capability of a register. Okay, already we discussed the storage capacity, how we can store a particular value. Now we can see how the registers can be used to for the movement of data. So there are different types of registers. We can see the first one. There are actually 4 registers. Okay, the first one, 1, 2, 3, 4. So it can hold 4 bits. Now we'll discuss the working of a serial in shift right, serial out. Means we are entering a value at the extreme left side, and when you apply each clock pulse, the value will be moved to the next register. Okay. And each time when you apply a particular clock signal, a value will be shifted from left to right. Okay, so this is called a shift right register, or we can call it as a serial in, serial out. So output is taken from the last register, input is given to the first register. So this particular arrangement is known as a serial in, serial out. Okay, serial in, serial out. The same thing can be operated in right shift mode or in left shift mode. So the second figure shows actually the left shift mode. Here the input is, you can see at the right side, and output is taken from the leftmost register. So each time when you apply a particular clock signal, the value will be shifted to the next register, and finally you will get the output. So this is called a shift left. Again, it's a serial in, serial out, but it's a left shift. Now we can discuss parallel in, serial out. The values are entered into the register parallelly, or at the same time all the values are entered into the flip-flop. For example, 1010 is entered into the register 1010, and after that applying each clock signal to get out of this particular register. So data out is serially, so this is serial, but the values are entered into the flip-flop by using a single clock signal. So parallel in, serial out. So next one is, here you can see the input. Input is applied serially. Okay, this is a serial input, but values are, once all the values are entered into the register by using a single clock pulse, you can take all the values through this output line. So this is a parallel output line. So serial in, parallel out. So next category is parallel in, parallel out. So values are entered into the particular flip-flop by a single clock pulse, and by applying another clock pulse, you can access all these values at the output side. So parallel in, so this is parallel in, and this is parallel out. Okay. And the two more modified version of the serial in, serial out, that is known as a rotate right and rotate left. So in the first case, you can see that data out is taken from the last register, but here you can see that the last register is again connected back to the input side. So in this particular arrangement, the values are rotated towards right, and here you can see this is a left shift, and the data out line is connected to the data input line in this particular manner. So this is a left shift actually. So if you are fed backing the output side to the input, then it is known as a rotate left. So this is a data movement in shift register. Now we will discuss different types of shift registers. They are known as SISO, serial in, serial out register. So serial in, serial out shift register. Serial in, parallel out shift register. Parallel in, serial out shift register. Parallel in, parallel out shift register. So there are mainly 4 types of shift registers. First, we will discuss serial in, serial out shift register. In serial in, serial out shift register, so this is a basic arrangement using a D flip-flop. So here you can see that 4 flip-flops. It is labeled from flip-flop 0 to flip-flop 3. The output lines are Q0, Q1, Q2, Q3. And this is the data input line, and this is the data output line. And here you can see that a synchronous clock is connected. Okay, it's a positive edge triggered clock. And this is a basic arrangement. The output of the first flip-flop is connected to the input of the second, and similarly it will continue. Okay, so the Q output of the first flip-flop is connected to the, that is Q0. Q0 is connected to the D1 input. It will be D0, this is D1, and this is D2, and this is D3. You can see that the Q0 is connected to D1, Q1 is connected to D2, Q2 is connected to D3. And we will see the working of this particular register, serial in, serial out register. So there is only one input line and one output line. There is serial output line and one serial input. So serial in, serial out. So we can consider this particular example. A 4-bit, okay, it's actually 4-bit. 1010 be sent in serially into the register. So we'll see how this register will work for this particular data 1010. So we want to enter 1010 into this 4-bit shift register. Assume that initially all values are 0. So here you can see that all values are 0. Here it is 0, 0, 0, 0. Okay, and the data input of now we can see that we are going to apply clock signal. So this is a clock signal. Okay, so during the first clock, okay, this is the first clock signal. During the first clock signal, you can see that the first data input, so that is the D input is 0. So when you apply this particular clock, so all these values are synchronous clock, this 0 will be transferred to the output side. Okay, and you can also see that in the previous case, the value at the FF1 flip flop is 0. So this 0 will be transferred to the output side. And similarly, this value of the previous value is transferred to the output side. Okay, now we can see that after applying the first clock pulse, the flip flop output is 0, 0, 0, 0. Okay. Now we can see the second clock. So first value is 0 that we already ended. Now we need to apply 1 here. So now we are going to apply 1. So there's a second clock. So during the second clock pulse, the D input is 1. So when you apply the second clock signal, positive edge trigger, this 1 will be transferred to the output side. Okay, and the previous values. Okay, see when you consider the FF3 previous input is 0. Okay, so that 0 will be transferred here, and here also this 0 will be transferred to this point. Here this 0 will be transferred to the output side. Okay, and now we can see that the third clock pulse. During the third clock pulse, the value is 0. So D input is 0. So D input is 0. So this 0 will be transferred to here, and the previous values will be shifted to the next flip flop. So this is 0. That 0 will be transferred here. Again, this 1 will be transferred to this point. Okay, the present input D is equal to 0 will be transferred to the output side of the first flip flop FF0. Okay, now we can apply the fourth clock pulse. During the fourth clock pulse, we are applying the last input, that is 1. Okay, so when you apply the fourth clock pulse, here D is equal to 1. So this D is equal to 1 will be transferred. In the previous case, the FF1 input is 0. So this 0 will be transferred here. Okay, for the FF2, the previous input is 1. So that 1 will be transferred to this point. Okay, and the last 0. So after the fourth clock pulse, you can see the output of the flip flop register is here. You can see that it is 1, and here it is 0, and here it is 1, and finally it is 0. So you can see that the 4 values now stored in this particular register. If you are not applying any clock, this value will be maintained. Okay, this is the working of serially. Now we need to see how we can take the value serial out. Okay, once all the values are stored inside the register, now we need to take the value serially at the output side. So this is the present state that all values are here. You can see that 1 and 0, 1, 0 is stored in this particular register. So after applying the 4 clock pulse, so the registers contain 1010. Okay. Now we are going to apply the fifth clock pulse. Already we applied 4 clock pulses. So here you can see that after this is the first clock, this is the second one, third one, fourth clock pulse. After applying the 4 clock pulses, the output or register contain 1010. Now we are going to apply the fifth clock. Okay. So during the fifth clock pulse, this 0 will be shifted to here. Okay, this 1 will be transferred to here. This 0 will be transferred here. This 1 will be transferred to here. This particular flip flop. Okay, and now again we are going to apply the sixth clock pulse. So when you apply the sixth clock pulse, again 0 will be entered into the particular flip flop, and all values are shifted. So the previous input is shifted to the output side. Okay. Okay, now we can apply the seventh clock pulse. So again, this 0 will be transferred to the output side, and all the previous value will be shifted to the next flip flop. Okay, now we can apply the eighth clock pulse. Now we are going to apply the 8th clock pulse. So now the output is 0001. Okay. Now we are going to apply the 8th clock pulse. The final 0 will be ended here, and all the previous values shifted to. So now we can see that after applying the 8th clock pulse, again all the register values are 0000. So all values are shifted out. Okay, this is the working of serial in, serial out shift register. Now we can see the waveform of this particular shift register. This is also important. You need to draw the waveform in each type. So here you can see a 5 flip-flops or a 5-bit register. You can call it as a 5-bit register because it contains 5 flip-flops. It's a serial in and serial out. Okay, one input line and one output line. And there is a clock signal. It's a synchronous clock and a positive edge triggered clock. Okay. Assume that all registers initially cleared, that all values are 0 initially. So output of all these registers are 0 initially. So before applying the clock pulse, so this is the first clock pulse. Before applying the clock pulse, all values are 0. So from this we can see that Q0 to Q4 is 0. Now we can see that in this particular question, the data values are given. So this is a random sequence is given, and for each clock pulse, you need to identify what will be the output. Okay. So before applying the clock pulse, okay, this is the first clock signal. So this is the first clock signal, and the D input is 1. Okay. After applying, so this D input is 1, which is waiting to enter into this particular flip flop. This is the present state. Now we are going to apply the first clock. So when you apply the first clock, this 1 will be transferred to this point, this 0 will be transferred here, and a shift operation take place. Okay. So what will be the present state? Okay. So this 1 is reached at Q0. Okay. So you can see that the Q0 output will be 1 and all other values are 0, 0, 0. Okay. Because when you apply the clock signal, the data input is 1, so that will be transferred to the output of Q0, and Q0 previous output is input is sorry, this is D0, D1, D2, D3, D4. So D1 input is 0, so that 0 is transferred to the next state. So you can see that this is a state after applying the first clock pulse. Okay. Now you can see that we are going to apply the second clock signal. So this is a second clock signal. When you are going to apply the second clock signal, you can see that D input is 1. So this is given in this particular question. So it's actually given that clock signal and the circuit is given. We are actually plotting this Q0 to Q4 output. So these two quantities are given, okay, for a particular input. So in this particular case, D input is again 1. Okay, the present state is 1, 0, 0, 0, 0, and now we are going to apply 1. So now we are going to apply the second clock signal. So this D input is transferred to here, okay, and this 1 will be transferred to here, and this 0 to next, and 0. Okay. So we can see that again the Q0 output is 1 and Q1 output is 1 and 0, 0, 0. Okay, because this Q0 is transferred to the Q1. Okay. Now we got the present state. Now again we can apply the next. So the present output you can see, which is 1, 1, 0, 0, 0. Now we can see that the before applying the third clock pulse, D input is 0. So now the D input is 0. Now we can see that this 0 will be transferred to the output side. This 0 will be transferred to the next state. This 1 will be transferred to the next state. This 1 will be transferred to the next state, and 0 will be transferred to the next state. So after applying the third clock pulse, the Q0 will be 0. Okay, and D1 will be 1, and D2 will be Q2 will be 1, and the remaining two values are 0. Now we can apply the next input. When you apply the next input, that is fourth clock pulse. During the fourth clock pulse, the D input is again 1. So here it is 1. And the present state is 0, 1, 1, 0, 0. So again, when you apply the fourth clock pulse, this 1 will be transferred to the next. The 0 will move to here. This 1 will move to here. And this 1 will move to here. And the 0 will move to the Q4. So after applying this, it becomes 1, 0, 1, 1, 0. Okay. Now we can apply the last clock pulse, fourth clock pulse. So during the fourth clock pulse, fifth clock pulse. Now we are going to apply the fifth clock pulse. At that time, D input is 0. The D input is 0. Present state is 1, 0, 1, 1, 0. Now we can see that this 1 will be transferred to the output side. This 1 to here, 0 to here, 1 to here, and this 0 will be here. So you can see that Q0 will be 0, 1, 0, 1, 1. Okay. The entire value will be shifted. So if you observe after the fifth clock pulse, you can see that output of Q4 to Q0. So Q4 is 1, and Q3 is 1, Q2 0, Q1 is 1, and 0. So we can see that after applying this particular clock signal, 5 clock signals, the value 1, 1, 0, 1, 1, 0, 1, 0 is stored in this particular place. So after applying the 4 clock pulses, the value at each flip-flop is 0, here it is 1, here it is 0, 1, and finally 1. Okay. So now we will discuss serial in parallel out shift register. So if you compare with the previous case, here you can see that data input is C. So only single input line, but you can see 4 output line. Okay. So each time, so in order to store 4-bit value to this particular register, you need to apply 4 clock pulses. So when you apply 4 clock pulses, all the values are moved into this particular register. Okay. So this is Q0, this is Q1, and this is Q2, and this is Q3. Okay. For example, this value 1100. When you apply 4 clock pulses, this value will be stored into after applying 4 clock pulses. 4 clock pulses are required to store this value. After the 4 clock pulses, all values are available at the output. Okay. So this is a simplified block diagram of this particular serial in parallel shift register. Okay, here you can say D input and a clock signal Q0, Q1, Q2, Q3. A single clock pulse is required to get the output value. Now we can see. Now we can see one example. Show the states of 4 bits which is stored in this particular register, and how we can take the output value. So assume that all values are 1 initially. Okay, all values are 1 initially. So this is a given question, and the data input is given, and the clock is also. This is a given in the question, clock signal also. So initially, before applying the first clock pulse, all values are 1, because it is given in the question that Q0, Q1, Q2, Q3 is equal to 1. So this is a D input, and the present D input is 0, and it's a positive edge triggered clock. When you apply the first clock signal, it is saying that this 0 will be moved to the Q0. Okay, so all other values will be 1, 1, 1. So after applying the first clock signal, the first 0 will move to the Q0. So Q0, the 0 will move to Q0, and all other values are 1, 1, 1. Okay, 1, 1, 1. Okay, now the second input is D is equal to 1. So before applying this, D input is 1 here. So now D input is 1, and now we are going to apply the second clock signal. So this is first click, this is the second clock signal. So during the second clock signal, D input is 1. So the values are shifted like this. Okay, and this 1 will be stored in Q0. So Q0 will be 1, and it will be 0, 1, 1. Okay, now we got the next stage. So now we can see third clock signal. Third clock signal D is again D input is equal to 1. So D input is equal to 1. And now we can see that the present state is 1 0 1 1. When you apply the third clock signal, the values are moved like this. Okay, this value will move to here, this is to here, and this 1 to Q0. So this is 1, and this 1, and this is 0, and finally 1. And now we are going to apply the fourth clock signal. So during the fourth clock cycle, D input is 0. So D input is 0. Okay, so the present value is 1 1 0. So now when you apply the clock signal, the D input 0 will enter into the Q0, and each value is shifted to right. So okay, and you can see that Q0 becomes 0. Okay, and Q1 is 1, Q2 is 1, and Q3 is 0. Okay, 1 1 0. So this is working of serial in parallel. Okay, so after applying 4 clock pulses, we can see the value 1 0 is entered into the output side. 0 1 1 0 is at the output side. Now we'll discuss parallel in parallel out shift register. It's a very simple thing. So in this particular figure, you can see this is a negative edge triggered clock, or it can be positive edge also. And there's a D flip flop. Here you can see the data input D0, D1, D2, D3 is considered as inputs. Here you can see the circuit diagram is different. In the previous case, the output is connected to the next input line. So here all inputs are separate. So this is a parallel data input line. Okay. All values are entered at the same time. Previously it's a single input line. Now it is a 4-bit parallel input line. And when you apply clock signal, all values D0, present value of D0 will be moved to the Q0, D1 value to Q1, and D2 value to Q2, and D3 value to Q3. So at the same time, you will get Q0, Q1, Q2, Q3. So Q0 is equal to D0, Q1 is equal to D1, and Q2 is equal to D2, and Q3 is equal to D3. At the same time, you will get output. Okay. So this is a parallel shift register. Now we'll discuss parallel serial out shift register. Okay. So data should be entered parallelly, and output will take from a single line. So serial out, parallel. So 4 input line D0, D1, D2, D3, 4 input line, 4 input line, and 1 output line. So this is a 4-bit parallel serial out shift register. So here we need to add some extra control signal, that is shift and load. So in order to perform shift operation, we need to use one mode, and in order to store the value D0 to D3 into this particular register, we need to use another control signal. So first we can discuss the load mode. Here you can say shift bar, load bar. Okay, load is an active low signal. So when you apply a low signal here, low signal or 0, okay, you can see that this is a NOT gate, so output becomes high. So G1 one input is 1, and G2 one input is 1, G3 one input is 1, and G4 one input is 1. We can say that G4, G1, G2, G3, G4 becomes active. And you can see that the lower line is 0. If it is 0 means the one input is 0. So G5 one input is 0 means it's an AND gate, so output is 0. G6 one input is 0 means output is 0. And another case here you can see that G7 input is 0, so output is 0. Okay, so the active gates are G1, G2, G3, G4, and whatever values in D0 will be transferred to the input side. So here you can see the one input is 1 and another one is D0. So D0 will be the output, and here D1 will be the output, and here it is a OR gate. So one input is 0, another one is D1. So you will get D1. Here it is D2, and the output of this particular G3 AND gate is D2, and here we will get D2. Okay, and the last here you can say D3, G4 output is D3, and this OR gate output is D3. So you can see that D0, D1, D2, D3 inputs will be available at the input side of the flip-flop. Okay, when you are using the mode control signal is low, or when the load signal is active low. Okay, so this is a load operation. Now, if you are applying any clock signal, the value will be transferred to the Q0, Q1, Q2, Q3. Okay, the parallel loading is take place. Now we will discuss how the shift mode will operate. Okay, so only a single output line. Already assume that the values are stored in this particular register. Now this signal is high, or we are applying 1 here. So this is a NOT gate. So here it will be 0. So G1 will be 0. G2 one input is 0. G3 one input is 0. And G4 input will be 0. So here you can see that this is 0. And here it is 0. G3 is 0. G4 is 0. So active, the lower values are 1. So here you can say G5 one input is 1. G6 is 1. G7 is 1. So active registers are, okay, not G1. Okay, G1 is also inactive. Okay, G1, G2, G3, G4 becomes inactive. Now you can see that already Q0 value is here. That Q0 value will be available at the input side. So G5 output is Q0, and here we'll get Q0. So D input is Q0 here, and here it is Q1. So AND gate output is Q1, OR gate output is Q1. So the second input is Q1, and the last one here it is Q2, and here it is Q2, and the last stage input is Q2. So the previous values of the flip-flop is moved to the input of the next flip-flop. Okay, so they are making a connection between the output and input. So it will similar to the shift register which is connected in a serial. And each time when you apply clock signal, the values are moved from one stage to another stage. Okay, so this is the working of parallel serial out shift register. Okay, the values are stored first time it will stored into this particular register, and each time when you apply clock signal, values are taken from the last stage of the shift register. Okay, now we'll discuss the modified one, that is a 4-bit bidirectional shift register. This is also very important. Okay, by using a single shift register, it can perform both left shift and right shift operation. Okay, so there's a mode control, and if mode control M is equal to 1, it will operate as a shift right operation. So we can see the first operation. If it is 1, it becomes 0. Okay, if it is 1, AND gate 1, AND gate 3, AND gate 5, AND gate 7 will be active, and AND gate 2, 4, 6, 8 becomes disabled. Okay, and here you can see that serial shift right input. Okay, serial right shift. So 4 flip-flops. Okay, the first value is entered here. So this is the first value, D input, and this value will enter into the first. So here you can say the D will be the, so this is D input, this is actually mode control. So D will be the first, here you will get D input. And similarly this Q3 becomes, this Q value will be the input here. Again this Q value will be the input to the next. Again this Q value will be the input to the next. Okay, this is the 4-bit bidirectional shift register and the shift right operation. Now we'll discuss the left shift operation. When it's a left shift operation, the mode control signal is 0. 0 means the 1, 3, 5, 7 AND gates are disabled. So output of this particular AND gates are 0. And here we'll get 1 because it's a NOT gate. So 1, 4, 6, 8 will be active. Okay, and if this particular AND gates are active, you can see that there is a data input line from the left. So okay, that value will be applied at the, so this is a D input from the left side. So this will be D and this will be D. And for the second flip flop 1, so you can see that this Q will be moved to here, and here will get Q. And again this Q, okay, will be moved to the 4 input, and here will be Q. Okay, again this Q will be moved to the AND gate input and input. So it will operate as a left shift operation. Okay, left shift and right shift. Okay, this is all about shift registers. Now we need to discuss another topic, some counters. It will operate based on the principle of shift register.